Well, hello Internet, and welcome to part 10 of my object-oriented design tutorial. Today I'm going to talk about GRASP, or the General Responsibility Assignment Software Patterns. You can just think of this as some tricks or rules to assign proper responsibility to the objects you create. So let's get into it. Now, what exactly is GRASP going to do? It's going to help you create good object-oriented designs, and there are 9 GRASP patterns or rules. Just think of these as simple rules. There's the creator, the expert, low coupling, controller, high cohesion, polymorphism, pure fabrication, indirection, and protected variations. I'm going to cover the first 5 in this tutorial, and then to end the whole object-oriented design tutorial, I'm going to cover the last 4. So what is the creator rule? Well, basically when defining or figuring out what will be an object that will create another object, which is our goal here, you should know that object A should create object B if object A contains object B, or object A saves object B to a file or database, or object A uses object B in some way, or object A has all the data needed to instantiate object B. And in most situations, more than one of these 4 rules is going to be true. So let's use a real world example here, and I'm going to start writing some code to explain this stuff. Let's say you need to create a bike object. Now there's different ways where you could do this. You could create a wheel class and a frame class, and then have those objects passed into bike and then create bike that way. But as you can see, bike is not creating the wheel really. It is just assigning it and storing it inside of here, while the wheel constructor is actually getting the width of the wheel and creating the wheel object, and the frame is also getting the length of the frame and creating the frame object, and then that is being passed over to create the bike. It's much better to create the wheel objects or instantiate them directly inside of bike, and I'm going to show you why here in a second. So here we are, we're going to write ourselves some code, and I'm going to present this in 2 different ways. One in which the wheel and frame objects are actually created outside of bike, and then whenever they are actually created or instantiated inside of bike. So we're just going to go private and frame the frame, and then we're going to create our constructor for bike, which is going to be passed wheel. This is the not so right way of creating a creator or following the creator rule. And then we're going to just simply come in here and say the wheel, which is up above, is equal to new wheel object that's passed inside, and the frame is equal to new frame that is passed inside. And then just to keep this brief, I'm going to put main inside of here, even though I normally wouldn't do this. And then we would go wheel is equal to new wheel, and then we define its width as 24, and then we go frame is equal to new frame, and let's say it's 52 inches long. I don't know, I'm just guessing about this stuff. And then we would create our bike is equal to new bike, and then pass in the wheel and frame objects that we just created. And then of course we need to go inside of wheel and create that private int width, and then create our wheel constructor. Width is equal to new width. And then we could save that, and then we're in essence going to do exactly the same thing inside of frame, length, and then go frame. And one of you guys told me to always type this information out because you don't like it when I copy and paste. So from now on I'm going to try not to copy and paste so much. And there we go. So we created both wheel and bike. Now, however, let's say I want to create or instantiate wheel and bike inside of here. I'm going to show you how much easier it is going to be to create, and it's also going to make a lot more sense to instantiate wheel and frame inside of bike. All I'm going to do here is I'm going to create a different constructor, and instead I'm going to actually build the bike totally inside of here by passing in the length of the frame and the width of each wheel. So bike is actually being built directly inside of bike. Then we're going to go the wheel is equal to new wheel by passing it wheel width, and then we're going to do the same thing for frame. New frame and frame length. And now, instead of creating wheel and then creating frame, which are all the things your user would have to do, now to create a bike, they could just simply go bike2 is equal to new bike, and then define how big the wheel is, how wide it is, and how long the frame is. So this makes a lot more sense. We just created a bike pretty simply instead of typing all of this out. So that is an example of what you should shoot for when you are following the creator pattern. This makes more sense, this one line in comparison to this three. And the only thing that's different is we instantiated wheel and frame inside of here. And that is exactly what we have here. This is going to allow the user to provide parameters instead of forcing them to create parts of the bike. And that's what you want to shoot for. And that is basically the creator pattern. Now, there are other ways to improve the creator pattern. Of course, if classes are very similar, you want to extend them from either a class or an abstract class or an interface. And of course, you want to always implement getters and setters for all of your classes. And if you need to save or load class information from files or databases, that should all be done inside of a class. And now we move on to the expert pattern inside of Grasp. Now, if an object A is going to instantiate object B, it must have all the information it needs to create it, as we saw previously. If we're going to be building wheels and frames inside of the bike class, we need to get the wheel width and the length of the frame. In other words, object A, or bike, must be an expert on how to create object B, or the object's wheel and frame. And really, that is all you need to know. If you're going to create a creator object, it must have all the pieces to be able to create all the pieces that make up the final object. Real simple. And now we get to something extremely important, which is low coupling. Now, a class with high coupling relies on many other classes for it to work properly. And a class that has high coupling is not going to be reusable. It's going to be hard to understand in isolation, and it's going to be very easy to break if other classes that it relies on change. So let's take a look at a code example to make this make a lot of sense. Alright, so what I'm going to do here is I'm going to build the wrong way to do it, and then I'm going to show you the right way to do it. So we're going to come in here and we're going to create a monkey class inside here, monkey.java. Then I'm going to make all the code available in a link underneath the video. So what are we going to do? This is going to be pretty simple, but I'm just going to go string name. And remember, this is the wrong way to do it. This is going to be a high coupling situation, and then I'm going to show you a low coupling situation. And this whole program basically is just going to store different animal names inside of it. And to a certain extent, this is also going to show you the strength of polymorphism and one way to use it, which is going to be covered in the next part of the tutorial. And then I'm just going to put toString inside of here so that if the object is called, it is going to export. If the object name, being monkey, is going to be inside of system.out.println, for example, it's going to print out this line or this string. And there we go. So there that is, and that is our monkey. And then we're going to do pretty much exactly the same thing with a lion. So just need to come in here, private string name, same exact thing that we did before. Create the constructor, which is going to be passed a string, which is new name. And then we're just going to assign name to whatever new name was passed over. And then public, going to return a string to string and return lion named, and then return the name of it. So then we'll jump back over into list animals and show you a high coupling situation. So here, what we're going to do is go private. Monkey is going to be stored inside here, a monkey object. And we're also going to store a lion object, the lion. And then we're going to go list animals, which is going to be the constructor, which is going to be passed a monkey. And it's also going to be passed a lion object. And I'm just going to go the monkey is equal to the monkey that was passed into it, and the lion is equal to the lion that was passed into it. And then public void, I'm going to display the animals in the zoo, for example, and you're going to see how limited this is here in a second. And then this is just going to go system.out.println, and because I have toString inside of there, whenever I call this is going to print out the string that I created in the toString function. And the same is going to be true here for whenever I call lion. And then down in public, in the main function, args, I'm going to create a monkey object, new monkey, and let's say I want to name him Max. And I'm going to create a lion, new lion, and I'm going to name him Tom. And then I'm going to go list animals, create this object here is equal to new animals, and then go monkey and pass it in the lion, and then go list animals. And if I want to display my animals that I have inside of here, I would do that. And that all looks well and good, and it's all coded properly. And if I go and execute it, you're going to see that it prints out monkey named Max and lion named Tom. The only problem is, what happens if I get a new member of the zoo that is a reptile? Uh-oh, now I'm going to have to come in here, and it's going to have to print out the reptile, and I'm going to have to change code here, and then I'm also going to have to come down here and change the code inside of here, and then I'm also going to have to come up to the constructor and change the code there. This is what we call a high coupling situation. This is bad. We do not want to do this because list animals is highly coupled to monkey and lion. And then on top of that, I'm going to have to change so much code. It's just overwhelming. So now I'm going to go in and show you how to do this the proper way using low coupling. And we're going to do that using polymorphism. So I'm going to come in here and create an animal class. And animal is going to have private string name like that. And then I'm going to create a constructor for it. Animal going to have a string new name, and it's going to do sort of the same sort of thing. You're going to see just this little tiny bit of code here that's in essence the same sort of thing, if done right, is going to provide an unbelievable level of structure, and it's going to be very, very flexible. And I'm just going to go return, and I'm going to put in animal, and you're probably thinking, well, it's not going to put the type of animal. Oh, yes it is. Just give me a second here. And there we go. So toString, got all that set up. And now we're going to go into monkey2, and we're going to extend animal and make this work and do a ton of other different things. And I'm going to do similar sorts of things. I'm going to go private string name. Actually, forgive me here for a second, because I'm not going to waste my time with that, because in essence all this is exactly the same. So I'm just going to copy it. So if you went and you typed out what was in monkey originally, you don't have to retype it. It's all right there. It's the same sort of thing. The only thing I'm going to do is I'm going to change this to monkey2, and then on top of that I'm going to come in here and type in super, which is going to be a call to the class that we're going to extend, which is animal. And that's it. That's all I needed to change there. So that's it, pretty simple. And I'm going to do the same sort of thing with lion. So I'm just going to copy this because it's exactly the same. Jump over into lion, and we're going to paste this right here. See, same sort of thing, same exact thing. The only thing that's different here is I'm extending the animal class. That's all. And then of course I got to make a call, new name, like that. And there we are, that's all set. And now let's get into list animals too, and let me show you how much more functional this is under a low coupling situation, in which it's not heavily tied into monkey and lion. So this time I'm going to go private array list, and I'm going to hold an array list of animal. Well, all of a sudden now I have so many different types of animals, an unlimited number of animals that I'm going to be able to throw into this guy. So that's great. New, and then this is going to be array list animal, just like that. Paste that there, throw that in there, and there we are. So now we got an array list that's going to hold all this, and this is giving me an error because I don't have the array list library inside of here. So there we go. Now I got it. What else do I need to do? Not much. I'm going to go public, void, add. I'm also going to make this feel more real, because if you're putting a new animal inside of your zoo, well, it definitely makes sense to have a method that would allow you to do that. And it does it in a very understandable way. We're just going to go add new animal, and now all of a sudden we're going to have all of our different animals added in a very logical way. Everything should feel like it's a real world sort of scenario. Animals don't just appear in zoos, they are put there. So display animals, we're using that. It's exactly the same, except in this situation I'm going to use an enhanced for loop. I'm going to go animal, animal, the animals, like that. And then system out, print line, and I'm going to print out my animals. See, now I can put out as many animals as I want. I'm not tied or restricted in any way to the number of animals I have in my zoo. And I also can have any type of animal as long as it extends the animal class. Then I'm going to go public, static void, main, just like we did before all the time. And now we're going to go animal, monkey is equal to new monkey2, remember? And then this guy's going to be named Max. And then we can create a whole bunch of these guys and go lion, for example. We can have anything. As long as I have another type of class for another type of animal type that extends animal, I can just keep putting these guys in here. See, I'll just go animal, lion2, just to show you. See, it's unlimited. Lion2, and then let's just say his name's Carl. There we are. And there's Carl. And now, list animals. 2, list animal is equal to new list animals. See, I don't even have to do anything with the constructor. Don't need one. And now if I go list animals, I can just go in here and type add animal to list and throw in my monkey that I created, add another animal, and throw in my lion. And there's lion 2, just to show you that it's unlimited. I can do as many things as I want. tons of flexibility. And then just go list animals, display animals, and call that method, and execute it, and boom, monkey named Max, lion named Tom, lion named Carl. And there is an example of low coupling. We're going to get the same results, but now we aren't tied to specific classes. And we can add additional classes without needing to change anything. It's awesome. And there's different levels of coupling. First, you have dependence, which just simply means a class depends on another class, but that class isn't a member inside of my class. So that just means that a class uses another class. And normally this is a situation in which an attribute or a variable or a value is passed over. This is an example of very low coupling. Then we have association. This is a class contains a reference to another class, or a situation where a class has a other class. And then you get into composition or aggregation, very, very similar. If you've seen past parts of this tutorial, you've seen that. This is a situation where a class holds an instance of another. This is owns a, or a class is part of another class. And then you have the highest level of coupling, which is inheritance. And this is where we either implement or extend another class. But here I showed you how to use inheritance in a situation in which those classes are going to have lower coupling than what they previously had. And it really comes down to you need to design classes that are independent so that changes in other classes have no or very little effect. You want to avoid creating subclasses, and if you do subclass, make sure that you subclass interfaces or abstract classes. And of course, you want to add flexibility and encapsulation of classes to avoid major problems from high coupling if you have to use it. Make sure your classes are flexible and encapsulated, and in that situation, coupling normally won't be an issue. Then we come to another pattern inside of this called high cohesion. This is a measure of how focused the responsibilities of an object are. It's very important to keep classes very easy to comprehend, maintain, and they also need to be reusable. You want to create classes that handle very few responsibilities for just one part of your system. That's the goal. Have many classes that handle all the little pieces of your system. And those classes should have very few methods and should work with other classes to fulfill any needs that would be considered more complicated. And if you are ever in doubt whether you have one individual class handling too many responsibilities, of course, delegate. And here, from my past examples, you can see an example of cohesion, and we have high cohesion, we have bank computer, which does so many different things, and yet, look at this, it's nice and tight and compact. And the same thing can be true for ATM, which we're going to see here in a second, which is going to use the controller pattern. It is also very tight and neat and compact and does only what it needs to do. So let's take a look at controller. This is the final part I'm going to cover in this tutorial. And whenever you're creating a controller, the question you're going to be asking is what object is going to stand between the UI and is going to coordinate all of the system operations. That guy is going to be called the controller. And in most situations, the controller is going to represent the device that the software runs in. In my ATM software example, the ATM object was the controller. And the controller is going to be used to handle and connect most other objects. And to easily figure out which object inside of your system is the controller, just look for the object that connects most of the other objects in your sequence diagram. So let's look at that. Here is the sequence diagram that we created previously in the past parts of this tutorial. And if you look at all these guys, you can see what is being called. What has most of the nodes that are being run over and over again. You can see this guy's passing information back and forth and constantly getting new information. And what is that guy? ATM. All these other little pieces have a couple nodes here and there, but ATM is overwhelmed. It has a ton of different nodes. So what does that tell you if you see this in a sequence diagram? ATM is your controller. And you can see an example here of ATM. Here's all the different things it's going to coordinate. It is going to first create itself by connecting itself to a network of banks. It's then going to check if my ATM card's readable, check if the ATM card's bank is in the network. It's going to handle insertion of the PIN. It's going to pick the account to access, the amount to withdraw, and then print out the final information for the transaction. ATM in this situation is my controller. And whenever you're creating systems using object-oriented design, you want to make sure you have a singular controller. And the main job of the controller is it's going to receive messages from the UI or the user interface, and it's going to forward those requests to the proper system objects. And this is going to lower coupling of the UI to those system objects. It's going to allow the UI to change dramatically or in any way without in any way affecting your overall system. It's very important to remember the UI should never handle logic or act as the controller, because if it does, that is going to dramatically limit the reuse of your system. The UI also shouldn't handle system events. Those should be handled by other objects inside of your system. And if you ever find or think that your controller is bloated, all you need to do is create many controllers and have each of those controllers represent different parts of your user interface. So that is the first part of Grasp. In the next part, I'm going to cover all the rest of the parts of Grasp, and that will be the end of the object-oriented design tutorial. Leave any questions or comments below. Otherwise, till next time.